Okay, we would like to use the Cauchy-Riemann equations to show that the function f of z equals x plus iy over x squared plus y squared is nowhere differentiable. In terms of z, the function is z over, and on the bottom here in the denominator we have the modulus of z squared. X squared plus y squared is the square of the modulus of z. So we would like to show that this function z over modulus of z squared is nowhere differentiable. And to do this, we'll use a theorem about partial derivatives of the real and imaginary parts, these so-called Cauchy-Riemann equations, which says that if f is differentiable at a point, then the partial derivatives of the real and imaginary parts satisfy an equation, two equations, u sub x equals v sub y and u sub y equals negative v sub x. These are the Cauchy-Riemann equations. So if these equations do not hold at a point, then the function cannot be differentiable. So that's what we're going to show happens to this function. We're going to show that either u sub x is not equal to v sub y, or u sub y is not equal to negative v sub x, or maybe both. So our function here, we can write it in terms of the real and imaginary parts. The real part is x over x squared plus y squared, and the imaginary part, v, is y over x squared plus y squared. And now we have to compute u sub x, u sub y, v sub x, and v sub y, and check to see if these equations hold. And we hope, since we're trying to show the function is not differentiable, we hope that they do not hold. So let's calculate u sub x first. As a function of x here, we're going to have to use the quotient rule, where we just think of y as being a constant. So the quotient rule says we have the bottom times the derivative of the top, where x is the variable, 1, minus the top times the derivative of the bottom, where x again is the variable, so that's 2x. The derivative of the y squared with respect to x is 0. And then we have over the bottom squared. And let's simplify this. This is y squared minus x squared divided by our denominator here. That's u sub x. And while we're at it, let's calculate u sub y. We'll use the quotient rule again. It's the bottom times the derivative of the top. And this time we're doing derivative with respect to y, so the derivative of the top is 0. And then minus the top times the derivative of the bottom with respect to y is 2y. And then all divided by the bottom squared. And this is negative 2xy negative, what's going on here? I'm having a pen problem. What is going on? Maybe there. Okay, I don't know what started it, I don't know what stopped it, but we're okay now. X squared plus y squared squared. Now, v is the exact same function as u, except with a y on the top, so I think we could just probably guess the derivatives of v. So I'm going to guess that v sub y is going to be just like u sub x, but with the x and the y switched, so it's going to be x squared minus y squared over x squared plus y squared squared, and I'm going to guess that v sub x is, this actually should be 2xy here, 2xy, I missed the y when I was having my cursor issues, so I think it's going to be the exact same thing here. It's going to be negative 2xy divided by x squared plus y squared squared. Yeah. Okay, so those are our partial derivatives. Now we want to check, does u sub x equal v sub y anywhere? here's u sub x, and here's v sub y. Those are negatives of each other. Those are negatives of each other. So the only place they could be equal is if the quantities are themselves equal to 0, which means that x squared is equal to y squared, which means that x is equal to plus or minus y. So that's the only time that u sub x is equal to v sub y. Now let's check the other pair. We need these two to be negatives of one another, and they're equal. So the only way for these to be equal and negatives of each other is if they're both 0. So that requires the numerator to be 0. That requires xy to be 0, which means that either x equals 0 or y equals 0. And putting these two together, we see that the only point where the Cauchy-Riemann equations can hold is at the point 0, 0. And the function itself is not even defined at 0, 0. So it's certainly not differentiable. F of 0 is undefined. 0 is not in the domain of the function. And in order for the Cauchy-Riemann equations to hold, I'll reiterate, either x has to be 0 or y has to be 0. And at the same time, x squared has to equal y squared. So that means x and y are both 0. And that's clearly not a point of differentiability of this function, since it's not defined at that point, at 0. So this function is nowhere differentiable. Z over modulus of z squared is nowhere differentiable.